How to calculate heart rate from ECG. An electrocardiogram, or ECG, measures the electrical activity of the heart over a period of time. It is detected by electrodes attached to the surface of the skin, and recorded by a device external to the body. Although heart rate can be calculated easily by taking a pulse, an ECG may be necessary to determine if there is any damage to the heart, how well a device or drug is working, whether the heart is beating normally, or to determine the location and size of the heart chambers. This test may also be performed to check for heart disease, to check for heart problems, or to determine if someone's heart is healthy enough for surgery. Method 1. Using the distance between QRS complexes. 1. Be aware of how a normal waveform looks on an ECG trace. This will allow you to determine what area of the ECG represents one heartbeat. From the length of a heartbeat on the ECG trace, you will be able to calculate the heart rate. A normal heartbeat contains a P wave, a QRS complex, and an ST segment. The one you will want to pay particular attention to is the QRS complex, as this is the easiest one to use to calculate heart rate. The P wave is a small semi-circular shape located right before the tall QRS complex. It represents the electrical activity of the atria, atrial depolarization, which are the two small chambers located at the top of the heart. The QRS complex is the tallest, most visible aspect of the ECG trace. It is usually pointy, like a tall, thin triangle, and very easy to recognize. It represents the electrical activity of the ventricles, ventricular depolarization, which are the two large chambers located at the bottom of the heart that forcefully pump blood throughout the body. The ST segment directly follows the tall QRS complex. It is actually the flat area prior to the next semi-circular shape on the ECG, which is the T wave. The importance of this flat segment, the ST segment, located right after the QRS complex, is that it provides important information to physicians about things such as potential heart attacks. 2. Identify the QRS complex. The QRS complex is normally the tallest part of the pattern that repeats on the ECG. It is a tall and skinny spike, for a person with normal heart function, that occurs repeatedly at the same rate across the ECG trace. Every time one QRS complex occurs, it is an indication that one heartbeat has taken place. Therefore, you can use the space between QRS complexes on the ECG to calculate the heart rate. 3. Count the space between QRS complexes. The next step is to determine the number of large squares on the ECG trace separating one QRS complex from the next QRS complex. The ECG normally has both small squares and large squares. Be sure you are using the large squares as your reference point. Go from the peak of one QRS complex to the peak of the following QRS complex. Note the number of large squares separating the 2 points. Often, it will be a fractionated number as the complexes will not land exactly on the squares. For instance, 2.4 squares or 3.6 squares may separate adjacent QRS complexes. There are normally 5 little squares embedded in each large square, allowing you to approximate the distance between QRS complexes to the nearest 0.2 units. Because one big square divided into 5 small squares gives you markings every 0.2 units. 4. Divide the number 300 by your answer above. Once you have calculated the number of big squares separating QRS complexes, let's use 3.2 as an example. Perform the following calculation to determine heart rate. 3.2 equals 93.75. Round your answer to the nearest whole number. In this case, the heart rate would be 94 beats per minute. Note that a normal heart rate is between 60 to 100 beats per minute. Knowing this can help to guide whether you are on course with your heart rate calculations. However, 60 to 100 beats per minute is only a loose guideline. Many athletes who are in excellent physical shape have lower resting heart rates. There are also disease states that can provoke unhealthy slower heart rates, called pathological bradycardias, and diseases that can lead to an unnaturally accelerated heart rate, called pathological tachycardias. Speak to a physician if the person you are calculating heart rate for appears to have an abnormal value. Method 2, using the 6-second method. 1. Draw 2 lines on the ECG trace. The first line should be near the left-hand side of the paper containing the ECG trace. The second line should be exactly 30 large squares subsequent to the first line. 30 large squares on an ECG trace represents exactly 6 seconds. 2. Count the number of QRS complexes between the 2 lines. As a reminder, the QRS complex is the tallest peak of each waveform that represents 1 heartbeat. Tally up the total number of QRS complexes between your 2 lines and write down this number. 3. Multiply your answer by 10. Because 6 seconds x 10 is equal to 60 seconds, multiplying your answer by 10 will give you the number of heartbeats that have occurred in 1 minute, in other words, the beats per minute, which is the standard measurement of heart rate. For example, if you count 8 beats in the 6-second period, then your heart rate calculation gives you 8 times 10 is equal to 80 beats per minute. 4. Understand that this method is particularly effective for irregular heart rhythms. If the heart rate is regular, the first method of simply determining the distance between one QRS and the next can be very effective, because the distance between all the QRS complexes is presumably the same with a regular heart rate. On the other hand, with an irregular heart rate, where the QRS complexes are not at regular distances from one another, the 6-second method works better because it averages the distance between heartbeats, giving a more accurate overall number.